Now we're going to continue on in Chapter 8, Section 2, talking about factoring. Now what we're leading up to is we're gonna factor things that might contain 4 terms. If you have 2 terms, okay, you're just going to factor out what you have in the 2 and pull out. If you have 3, you're going to do the same thing. You're going to factor what they have in common and pull out. When you get to a 4-termed polynomial, I don't like that one first. Hold on, let's start with an easier one. No, it's 8.2. It's in Chapter 8, Section 2. We're finishing that section. I only started part of the section the other day to let you kind of practice it before you kind of got a little deeper in there, okay? Okay, what you end up needing to do is when you look at it, I have 4 terms. Try and look at, I'm going to make all this plus for right now, okay? Just because I think it'll be easier on your first one. Look at grouping maybe just the first 2 terms and the last 2 terms and see if there's anything they have in common. So between the first 2 terms, what do they have in common? An n. So if I pull out an n, what am I left with? Okay. And if I look at the second set of terms, do I have anything in common there? No. So that was actually just going to stay r plus 5. Okay. What coefficient is out here? How many groups of r plus 5 do I have? Okay, so it's hidden, but everybody understands there's a 1 there, right? Okay. What do you notice about that grouping up there? What's almost the same? What is the same? r plus 5. So r plus 5 was a factor within your first 2 numbers, and r plus 5 happened to be a factor in your second 2 numbers, right? So when that happens, okay, when these 2 factors are the same, then I can group this as a factor. Because if you remember the distributive property, okay, when we started breaking up binomials to multiply by other binomials, that was our first step of rewriting it, was to separate the 2. So for me to put it back together, I'm going to put it right like that. And if you remember when we started using the FOIL method, this is what we had. Our first term times our first term. Okay, so when I broke it up, it was n times the r plus 5. And then it was the 1 times the r plus 5. Okay, so when you start factoring out, when you realize that these 2 sets are exactly alike, okay, you're going to take the things that are in front and make it a group as well. Okay, so let's look at another one. They start changing some signs, and I don't want to do that yet. Say I have that. So let's group the first 2 things together and the last 2 things together. Is there anything in the first set that I can pull out? X. So what am I left with? Okay. Anything in the second term? No. So what number's here? 1. And if you need to write 1, so when you go to group this, so now how is this going to look? What's going to go in this first set? X plus 1. And the second set? Okay. And you do not write the 2y plus 7 twice because he's up there. Okay? You're using the distributive property, so for me to regroup it, okay, that's like me maybe taking something away from you guys, okay? Maybe because I'm taking away from all the girls doesn't mean I'm taking more away from the girls than I am the boys or anything, okay? If I'm taking one away from everybody, I'll go around and take one away from everybody. Okay? Yes.
Where you got both sets have 2y plus 7.
Mm-hmm.
If you're, how in the end you only have one set of 2y?
Because x is being multiplied by 2y plus 7 and the 1 is being multiplied by 2y plus 7, right? Is all I'm doing is I'm handing out the x and I'm handing out the 1. So it's kind of like I'm coming back and repairing and saying, okay, instead of me handing out papers and Elijah handing out papers, I'm just going to give both my sets to Elijah to hand out. So that doesn't mean he goes around and gives everybody 2 of everything. He just has 2 papers to give to everybody. Okay? So he's still distributing the same information that he and I were doing, but only one person's doing it. And so that's why we group it back as one group. Okay? If you think back to when we did something like this, and I'm going to change it. Okay? And when we first started, before we did FOIL, and we said we're going to distribute, and I said you're going to take x and multiply by everything, and then you're going to take this 1 and multiply by everything. Okay? That's where I was a minute ago, but now I'm going backwards. Okay? So it's the same thing. It's kind of going backwards though. All right? So you're still giving it to the same group, and I know there's 2 groups of them, but it's still the same thing. So you don't write it twice.
If you're factoring that problem and factoring it, well, every problem, like how that you would take away x.
Right.
Will every problem have that?
No. Okay? Now tonight, this is what a lot of it's going to be. Okay? When it has 4 terms, you're going to be able to do that. We're going to go in and later in the next section, okay, and I'm going to show you how to factor of maybe you don't see what things are, and you go back to a trinomial, so you have a 3 term, but you can make that 3 term look right like this too, okay, and I'm going to show you how to do that. So it's a progressive state. Right now with 4 terms, you hopefully will be able to group 2 of them and 2 of them and come out. Now you may get to one that when you go to group, let's look at this one. Let's say you have 2xy plus 7x, okay? And then let's say somewhere in here I might have something like 2m plus p, okay? Well, let's put a 2p here because I want a 2 there. What comes out over here? X, and you're left with 2y plus 7, right? What comes out over here? 2. Now, can I write this as x plus 2 times 2y plus 7 times m plus b? No. The only time you can go into that common, the 2 binomials being multiplied, is when these 2 things are alike. Are those 2 things alike? No. I'm done. I can't do anything else right there. I have to stop.
That'd be the answer.
That's the answer on that one. Okay? Now, I won't say that it looks any neater than it did a minute ago, but you were able to factor something they had in common out. Now, sometimes you might want to rearrange things and see if you can see something else that maybe you can take more out of. Okay? But in this case, no matter how you rearrange that, you're not going to take any more out of anything than you already are. Okay? So sometimes you'll get to a point where you have to stop. The only time you rewrite it is when these 2 things here are exactly the same. Yes?
Why didn't you take the 2 out? Why did you take the x?
Because I said if I group these 2 things right here, The only thing these two have in common is an x. Okay? Now, is that going to say that that would have been any easier than me going, if I rewrote this, 7x plus 2xy plus 2m plus 2p? Well, I could have actually rewrote it as one of these ways and said, okay, I'm really not that much different. Okay, looks a lot different, but I still factored something out. Okay, but usually when you have four terms, try and group two of them together to see what you can pull out. Okay, let's look at another one. Okay. Look at the first two. Is there anything I can factor out of the first two? 3 what? P. And what's left? N plus 5. Okay. Anything I can factor out of the other one? -4. Did everybody see the -4? Okay. Now what's left? Is that minus? Okay, that's what it's going to be plus 5. Because let's think, when I distribute, what is -4 times n? -4n, which is what, good, right? What is -4 times -5? Positive 20. Okay, so you have to pay attention. If I'm pulling out that -4, okay, that's going to force him to be that plus. Now what do you notice? They're the same, so how am I going to rewrite that one? Okay. Now, let's say for some reason you might have, so right here on this step, maybe I went through and I said, okay, 3p and n plus 5, and then I'm going to pull out a positive 4. Well, then I'm going to have a negative n, right? Because I know these two things here have to be multiplied back together to make this negative right here, correct? So I could have put plus 4 here, but that would make that negative n. Well, again, when I do that, that's going to make that a -5, because positive 4 times a -5 gives me a -20. Well, now, do these things look alike? No. So what you can do is, if you notice at this point, okay, those don't look alike. Think in your head, have I done something? Both of these are negative, so pull out that -1. Okay, which is going to now make that -4, which is what we did in the original problem, okay? So sometimes you'll get caught up in doing the same thing, and you'll end up, and they look different. Okay? Just, it's not that you're wrong, so you don't have to necessarily erase anything, but just think, how do I change both of those from being negatives to positives? I've got to do something with a -1. Okay? Because a negative and a negative will make it positive. So even if you go this route, you can pull out a -1 next, which will make that just a -4, and you're right back to where we were. We're going to get one in a minute where we might see n plus 5, and then we might see a 5 minus n. Okay? And I'm going to show you the difference in that one as well, okay? So actually, let's just go ahead and look at that one. Let's say we have this. Okay? Well, let's look at the first two. Anything I can factor out? C. So that leaves me what? 1 minus 2d. Everybody see where I got 1? He's my spot holder. Okay? Now, plus, what can I factor out? I can do a 4. So what do I have left? 2D minus 1. Because does everybody agree 4 divided by 4 is 1? Does everybody agree with that? So that's, okay. Now, I got the right pieces, but they're in the wrong order, right? So how am I going to maneuver that? Do what now? Not plus a negative, but what happens if I go through and multiply by negative right here? Okay, so I can pull out a negative, but then what happens to this? That changes, okay? So if I pull out, okay, let's look here. Does everybody agree negative 1 times negative 1 is a positive 1? Okay. Let's say, though, but at this negative 1, I want to keep him in there for a minute. Because what happens here then? That becomes negative 4. Now, what happens if I distribute this negative 1 to this? Negative 1 times 2D is negative 2D. And what is negative 1 times negative 1? Now, do you agree now that I can rewrite that using commutative property and say that this was 1 plus negative 2D? And does everybody agree this plus and negative means the same as 1 minus 2D? Okay. Now, you do not have to go through all these steps. I wanted to show you where it was coming from, okay? Everybody understands you can take any number, multiply it by 1, and you haven't changed it, right? So the reason I pulled in this negative 1 and negative 1, because we know negative 1 times negative 1 is positive 1, right? So I've just added stuff in there, but it hasn't changed the looks of anything yet. Okay? Yes. So it's all from this step that you have to do is pull out a negative 1. So from this step down, you should have went C times 1 minus 2D. And then you can, if you wanted to write plus 4 times negative 1 here and flip this order, you could. Okay? Or at this stage here, if you wanted to make that just a negative 4, you could have done that as well. Okay? Ever how you visually wanted to see that one on your paper. Okay? Those are probably the hardest ones. Because you see what it is and you remember you've got to do something, but you can't remember what you got to do. Alright? Let's look at another one of those. Okay. Yeah, Davey.
I tried like putting after we got down to the where problems look the same.
Uh-huh.
When you take the thing where you got negative 4 times C.
Wait.
Get 4C.
Oh, I'm sorry. Oh, the bottom. Oh, wait. Are you saying down here? You would have C minus 4 and 1 minus 2D. Because now, see, they're exactly alike.
Okay.
So now I'm able to write that. Sorry, I didn't finish that. I was more worried about changing that last set of things around. Okay? Let's look at another one. Like I said, now those I think are the hardest because you see that they're supposed to be alike, but you can't figure out what you've done wrong. Alright? Let's say I have 15A minus 3AB plus 4B minus 20. Try that. You guys try that one really quickly. look at it. What are you going to pull out of the first two? Okay, all right. What now? I'm sorry. 3A. All right, so if I pull 3 out of this, what do you have left? 5. If you pull 3 out of here, what you got? Okay, so 1B, so I can just put B though. All right. Now, can I factor out anything over here? What? A positive 4. Okay. And what do I have? Okay, now what? Okay, let me ask a question. You can change either one. Which one do you want to change? Yeah, you can change this first one, same way. Change the second one? Alright, so we're going to go, then the first is going to stay the same. Alright, now what am I going to do? Minus 4. Very good. Now, the only way I can do that is, when I said right here you could change either one, the other way I could have done it was negative 3A, B minus 5, plus 4, B minus 5. And then I could have had negative 3A plus 4 times B minus 5. Those are those are both the same thing. Okay? Either answer is acceptable in that problem. Okay? Here was method A, which was changing the second set. B was changing the first set. Okay? You can change either one. So both answers are acceptable. They're both the same thing. Okay? Questions on that? Okay. The other thing out of this section is, after they get to somewhere, they're going to say, solve this equation. Now, let's think about this. I'm saying 3n times n plus 2 has to equal 0. So what do I know about anything being multiplied by 0? Well, no, let's just think. Go back to normal stuff. What is? 3 times 0 equals 0. So if one of those two things, one of these two things has to be a 0, right? For that to be true. Would you agree? So you're going to break this off now that you have the two factors, and you're going to say, well, okay, well, 3n has to be equal to 0, or n plus 2 has to be equal to 0. Now, they both can be equal to 0, but one of them has to be a 0, right? So now, you're going to solve both of these. So how do I solve for n? Divide by 3. So n is what? 0. Okay? What about this one? Subtract 2. So n would have to be negative 2. Now, let's go back and think about this. If I plugged in a 0, 3 times 0 is 0. And if I plugged a 0 here, that's 0 plus 2. 0 plus 2 is 2. And what's 0 times 2? Well, that works, right? All right, let's plug in our negative 2. 3 times negative 2 is negative 6. What is negative 2 plus 2? 0. So what is negative 6 times 0? So my two possible answers to make that statement true would be 0 or negative 2. Does everybody see what I did? No, on this one you can just list 0 and 2. Okay. Do it now. The negative 6, when I plugged in negative 2 right here. So basic, yep, you have to plug it in for both. When I go back, I don't plug a 0 here and a negative 2 here. Okay? If I plug a 0, I have to plug both zeros in here. If I plug in -2, I plug in a -2 and work it out. Okay, so if you plug in here, that means 3 times 0 plus, or times 0 plus 2, right? So that gave me 0, that gave me a 2, and then my final answer would be 0. Okay? So at that point when you finish, just to check yourself, just go back and plug it in. Alright, let's look at another one of those. Let's say I have something like 8b squared minus 40b equals 0, and I ask you to solve. Well, the first thing you need to do is factor it down as small as you can. So is there anything in common? What? 8 what? 8 what? I'm ignoring it. 8b. Okay, so what's left? B minus 5. Now what am I going to do from there? So I'm going to separate them. So 8b equals 0 and b minus 5 equals 0. And then from here, sorry, that's 0, okay, divide by 8. So b over here is going to be 0. And what am I going to do here? Add 5. And so b equals 5. So the two possible answers there are 0 and 5. Okay? Now the only time you have to worry about solving is if it actually in the direction says solve the equation. If it just asks you to factor the equation, this is not going to be there. Okay? They're going to put it equal to 0 or make you put it equal to 0 when they say solve the equation. Sometimes you might even have this. X squared equals 14x. How do you solve that equation? Let's get our x's on the same side. So that means I want to subtract 14x, right? So now I have x squared minus 14x equals 0. Now what are you going to factor out? X and now what? Split them out, so x equals 0 and x minus 14 equals 0. Now, there's nothing for me to do here. It already told me what my variable was equal to, right? Here, I can do the math, and I get x equals 14. Okay? So even if they start off and it's not equal to 0, manipulate it by doing the math to make him go to 0. Then factor out, set them both equal to 0 and solve. Okay? I'll slide back down, Davey. Alright, here's what I want you to work on for homework tonight. Oh, and tomorrow we are going to be in the computer lab working on using models. So we're going to actually be on the computers tomorrow using manipulatives to build stuff like this. We may not get quite up to this yet, okay? But we're going to get there, alright? Do what? Then I'll schedule another day.
We'll be here.
Okay. I think tomorrow we'll be here. Friday's the day that I'm iffy that we'll be here. Okay? Alright, here we go. Page 480. You should be able to do 21 through 44. Let's just do let's do odd tonight, just because those are in the back of the book and you're able to check your answers. So, page 480, you can tell her that, but remember, payback sure can come back to bite you in the butt. Okay? Because remember, you were absent quite a bit before Christmas, so you'd better hope that you wouldn't be absent anymore. Page 480, again, 21 through 43, the odd ones. So you might have maybe, what, 10, 15 maybe.